Hi all, I will be talking about Chapter 13, Data and Analytics today. Recognize the need for it and appreciate the capability of stream analytics and discuss about the applications of stream analytics. Now we will go over what is big data. Big data means different backgrounds and interests. Traditionally, big data means massive volumes of data, for example, data collected from NASA, Google, etc. Where does it come from? The big data comes from X to RFID to GPS systems to sensor networks, social networks, text documents, in data records, different fields of astronomy, biology, scientific research, you name it. We will next look at the data size starting with kilobyte, which is 10 to the power 3, to megabyte, which is 10 to the power 6, 10 to the power 9, 10 to 12, petabyte 10 to the power 15, on and on. So the data size is getting bigger and bigger. Next, the V's of big data. First one is volume, then velocity, veracity, variabilization, and we will talk about each of them, all these V's. They define the big data. Volume means amount of data. Variety means data in all types of formats, email, video, audio, text, XML, etc. Velocity means how fast the data is produced and how fast the data must be processed. Veracity refers to accuracy, quality, truthfulness and trustworthiness of the data. Next, it refers to the high inconsistencies of data flows with periodic peaks. And then the value proposition. By analyzing big data, organizations can business value. Big data by itself, regardless of the size, type or speed, is worthless. You out of it by doing big analytics and with the value proposition. Big data also challenges, for example, effectively and efficiently capturing, storing and analyzing big data, and we also need new tools for being able to analyze such huge volume of data. Next, we will be talking about some critical success factors. For big data analytics, first we need a clear business need, then strong committed sponsorship, between the business and IT strategy, a fact-based decision-making culture, a strong data right analytic tools, and we need the right people with the right skills. Next, we will be talking about some enablers of big data analytics, such as in-memory analytics, in-database analytics with massive parallel processing and appliances. As the size and complexity increase, the need for efficient analysis is also increasing. Computation and needs of big data, a number of new and innovative techniques and platforms have been developed. These techniques are called high-performance computing, which include in-memory analytics, in-database analytics, split computing, and appliances. In-memory analytics solves complex problems in real time with highly accurate insights by allowing analytical computations and big data to be processed in memory and distributed a dedicated set of nodes. Then in-database analytics speeds time to insights, better data governance by performing data integration and analytical functions inside the database repeatedly. Grid computing promotes efficiency, lower cost and better performance in a shared, centrally managed pool of IT resources, and appliances brings together hardware and software in a physical unit that is not only fast but also scalable on an as-needed basis. Some of the challenges of big data analytics are data volume, as we all understand. The ability to capture, store and volume of data in a timely manner is a challenge. Data integration. The ability to compete and at a reasonable cost, processing capability, process the data quickly as it is captured, which is also called stream analytics. Data governance, which in security, privacy and access. Availability of a data scientist and the return on investment. So these are some of the big data analytics challenges. Big data technologies. MapReduce and Hadoop. These are the two big players in data technologies. Then Hive, Pig, HBase, Flume, etc. They also play their roles. MapReduce distributes very large data files across a large cluster of machines processors. Goal is achieving high performance with simple computers. This is developed and popularized by Google, processing and analyzing large volumes of multi-structured data in a timely manner. Example tasks would be indexing the web for search, text analysis, graph analysis, etc. It's an network for storing and analyzing massive amounts of distributed unstructured data. It was originally created by duck cutting at Yahoo. Hadoop clusters run on in-memory hardware, so projects can scale out inexpensively. And Hadoop is now a part of Apache software solution, which is also open source. So there's hundreds of contributors continuously improving the core technology. So MapReduce plus Hadoop, they are the big data core technology. We will talk about who is a data scientist. A data scientist is basically a big data guru. Skills to investigate big data. Generally, they get very high salaries with very high expectations. You can be a data scientist if you have a PhD in MIS or computer science. Some schools now have programs in big data also. Okay. Next, we will be looking at some of the big data vendors. A representative list would include Map, also IBM, Oracle, Microsoft, Amazon, Google. They are all big data vendors. SAP has its own big data also. They are vendors. Top with primary focus on Hadoop. You can see MarkLogic, Cloudera, Tengen, MapR, Hortonworks, Datasto, Couchbase, Aerospike and Neo Technologies. These are some of the top 10 big data vendors. Lastly, we will talk about stream analytics. One of the V's in big data is velocity, speed. Analytic process of extracting actionable information from continuously flowing streaming data. And why stream analytics is important? Because it may not be the data, because you may lose its value. You may lose its value, it has to be analyzed while in motion. And some of the stream analytics applications are in e-commerce, telecommunications, law enforcement. This is analytics, not storing the data and then later on analyzing it. This is analyzing the data as it happens, as it is produced. In power industry, in financial services, health and government. This is essentially your chapter 6.